Okay, now we're going to run through 6b. Okay, on 6b you have a water slide. And the person starts and goes like that, and by the time he gets to the end, he's got a horizontal velocity Vx, and the ground is here, and he travels from here to here 5 meters in 0.6 seconds, and he hits the water. Now, while he's traveling horizontally, he becomes a projectile and travels vertically. So I have a Vx and a Vy. So there are two ways I can approach this. What they want me to do is find this height. So I can say that it's easy to get the height from here to here, which is the edge of the water slide. And then I can get dy, making him a projectile, and then h plus dy will equal the height of the slide down to the water top. So I'm going to solve for, I'm going to do it that way, and then we'll do it another way. H is what I'm looking for, so I'm going to say Ke at the top of the slide plus Pe at the top of the slide is equal to Ke at the bottom of the slide plus Pe at the bottom of the slide. So he starts from rest, so I have mg little h is equal to 1/2 mv at the bottom, and there is no Pe if I'm saying at the bottom it's 0. Masses will cancel out, so I can say that 2gh, oops, not what I want. I can say that gh is equal to 1/2 speed at the bottom squared. Well, if I use this 5 meters in this 0.6 seconds, I can get the speed at the bottom because it'll never change because gravity is not going to let it change. So distance over time will give me speed at the bottom. If I do that correctly, I'm going to get 8 1/3 meters per second. So I have 9.8 times h is equal to 1/2 times 8 1/3 meters per second squared, and I can solve for little h. And if I solved for little h, okay, I don't have that solution, so let me get a calculator real quick. So little h is 3.54 meters. Then I'm wanting to become a projectile, so I'm going to say, well, he's going to fall dy equals 1/2 gt squared plus vyi t. This is 0. So dy is going to be 1/2. G is 9.8. He's going to fall for 0.6 seconds. So if I take 4.9 times 0.36, I find that he falls another 1.764 meters. So big H is going to be the little h, which we found was 3.54, plus the little dy, 1.764 meters. So that's a 4, a 0, a 3, 5.304 meters is big H. Now there's another way to do that. I can say that here's my water's edge. Here's the big H that I was looking for. And I can say that Ke at the top plus Pe at the top equals Ke at the bottom plus Pe at the bottom. There is none at the bottom. There is none at the top. Now the only problem is I got to find the speed that he hits the water with. So there's a Vx here and a Vy. So Vx is going to be 5 meters over 0.6 seconds, or 8 1/3 meters per second. Vy final is equal to Vy initial plus gt. That's 0. So Vy final is gravity lasting for 0.6 seconds. So Vy final is 5.88. But that is not the speed he hits the water with, because he has two components. He has the 8 1/3 and the 5.88. So the speed that he hits the water with is going to be the square root of 5.88 plus 8 1/3. So the speed he hits the water with is about 10.2. So now I can go back and say, all right, well, mg big H equals 1/2 mv at the water squared. So now H is going to be 1/2 10.2 squared over 9.8. And I will get the exact same height that I did a minute ago, and that was 5.3 meters. This big H. So there's several ways to solve that problem. Okay, now let's go on to number 7. Number 7 says that a 74 kilogram student starting from rest slides down 11.8 high water slide. On the way down, friction does a negative 5,100 joules of work on him. How fast is he going at the bottom of the slide? So his mass was 74. His height was 11.8 meters. And the work done by friction was a negative 5,100 joules. So I'm going to say KEI plus PEI minus the work done by friction is equal to KEF plus PEF. I'm going to call the bottom of the water slide 0 height, so I'm going to cancel that one. I'm going to say that he started from rest, so there's none of that. So PEI minus KE final is equal to the work done by friction. So the change in energy basically is equal to the work done by friction. So mghi minus 1/2 mvf squared is equal to 5,100 joules. Now, I don't put the negative sign over there because I already took the negative sign into account right here. Okay? So I have 74 kilograms, 9.8, 11.8 meters tall, minus 1/2 74 kilograms, Vf squared, has to equal the 5,100 joules of energy eaten up by friction. So I do all my algebra and I solve for Vf, and if I do my algebra correctly, I got 9.67 meters per second. Okay, number 8. A 300 kilogram piano is being lifted at a steady speed, so the mass is 300 kilograms. Speed is steady, so all the forces are balanced, and it's going to go up a distance of 12 meters. And the crane that is doing the lifting process produces a steady power of 400 watts. And they want to know how much time is it going to take. Well, power is equal to work over time. So I need to isolate time, so time is equal to work over power. The work done is 300 kilograms times 9.8, because if you're going to lift it straight up, you have to exert a force equal to its weight. I'm going to lift it 12 meters. And my power is 300 kilograms. So I got my time to be 88.2 seconds. Number 9. A truck is traveling at 12.1 meters per second down a hill. So here's my hill, 12.1 meters per second. I don't know how long the hill is, so I'm going to call that D. and the angle is going to be 13 degrees. And the wheels lock. When the wheels are locked, the coefficient of friction between the tires and the road is 0.750. And they want to know how far does the truck skid before coming to a stop. So basically they're asking me what is D. So again, no spring, KEI, PEI, minus the work done by friction is equal to KEF plus PEF. Alright, so I'm just going to think about this for a minute. If he goes all the way to the bottom of the hill, then I can pick the bottom of the hill as zero potential energy. So that's gone. If he comes to a stop, that's gone. So KEI plus PEI will equal the work done by friction, because all the energy was taken away. So I have 1/2 mvi squared plus mghi is equal to mu mg cosine theta times d. Now, the reason it's mu mg cosine theta is if you think about this truck, remember there's the weight, there's Wy, there's the force normal. Force normal is equal to Wy. Friction is mu times force normal. Okay, well let's see. That can go away, that can go away, and that can go away. Well, I have an HI and I have a D. Don't know the HI. But I can say that the sine of 13 degrees is equal to HI over D, or HI is equal to the sine of 13 degrees times D. So I have 1/2 BI was 12.1 plus G 9.8. HI is the sine of 13 degrees D is equal to mu. And then mg cosine theta, that's going to be, alright, I know my mu, so let me quit messing around here. 0.75, 9.8 times the cosine of 13 degrees times D. So I'm going to combine all my D's on one side. And if I do that correctly, then I eventually can solve for D, and hopefully I will get 14.76 meters. All right, there you go.